Hello, I welcome you all to this another interesting screencast, and the problem reads the towline exerts a force P equal to 4 kilonewtons at the end of the 20-meter long crane boom. If X is equal to 25 meters, determine the position theta of the boom so that this force creates a maximum moment about point O. What is this moment? This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So first things first, let's assign some details. So let's call this angle here is phi, right? And then from A to O, let's call this angle here let's call this angle here is alpha, and so is this one as alpha, and then let's call this one as beta. Beta. Okay, let's call this one as beta. Let me also use red here. I call this as phi. Great. First things first, we know that for us to find the moment about point O, which is maximum, let's first write just a general equation for the moment about O. Point O, this is going to be equal to the force times the lever arm sine phi. So we know that when phi is equal to 90 degrees, then MO becomes maximum about point O, which will just be equal to F times R, because sine 90 is 1. Right, so which we already know, we'll calculate it, right? But let's calculate alpha, right? We can calculate what alpha is because we've been told that X is equal to 25 meters, right? So using Pythagoras theorem, we can say that alpha is just going to be equal to tan inverse of opposite, which is just 1.5, divided by the adjacent, which is 25. Okay, and therefore our alpha will just be equal to, grab your calculators, so we have a 3.43 degrees. Okay, 1.5 divided by 25, tan inverse of that is 3.43 degrees. So that is our alpha. Then we also know that the summation, the total internal angle in a triangle is equal to 180. And then we've also identified this phi, because we are saying for us to have the maximum angle about point O, we need phi equal to 90 degrees. Okay, this is the condition that we are told in the problem. Therefore, if this is the case, beta will be equal to 180 minus phi, which is 90, minus alpha, which we just found is 3.43, minus theta. Okay, and therefore our beta will just be equal to 180 minus 90 minus 3.43. This gives us 86.57 degrees minus theta. Okay, 180 minus 90 minus 3.43, 86.57 minus theta. So this is our beta, this is our beta, right? So we can also find the length of OA using Pythagoras. So the length of OA will be equal to square root the length of AA will be equal to square root of 1.5 squared plus 25 squared. Great. So it's like we have all the information that we need. Let's plug in, let's use the sine rule to find what theta is. Alright, since we are interested to find theta, so that the force creates a maximum moment about point O and later on calculate moment, which is just quite direct. So using sine rule, we'll say sine 90 or sine phi divided by the length OA. This is going to be equal to sine beta divided by the length OB. Alright, so we know what OB, we know what OA is. We can replace this, therefore sine 90 divided by OA, we said it's just square root of 1.5 squared plus 25 squared. This is going to be equal to sine beta. Beta, we said beta, this is going to be equal to 86.57 degrees minus theta divided by OB, and OB is just 20 meters. Great. So with that information, let me just draw a boundary here. Let me draw a boundary there. Great. Maybe I just move it a little bit. There. Okay. So let's solve this. So we'll say sine 86.57 degrees minus theta. This is going to be equal to 20. Sine 90 is just 1. So this is 20 divided by, I can write a whole lot of it. So it's 20 sine 90, we know sine 90 is 1, I just wanted to include it there, and divided by root of 1.5 squared plus 25 squared. Okay, then writing this by making the angle itself subject to the formula, then we'll have 86.57 minus theta is equal to sine inverse of 20 sine 90 divided by square root of 1.5 squared plus 25 squared. Alright, so we have 86.57 minus theta equals to, let's find what that is. So 20 divided by, let me start with 1.5 squared plus 25 squared. Square root of that is that 20 divided by that, and then sine inverse of that. So we have this equal to 52.99. Let me just come again. 20 divided by square root of 1.5 plus 25 squared. Okay, sine inverse of that. Alright, therefore our theta is just going to be equal to, theta is equal to 52.99 minus, so we have 86.57 minus 52.99. So we have theta equal to 33.58 degrees. Alright, so that is our theta. And then we know the moment. Let's find the moment. We said the equation is equal to, this is equal to FR, where F is equal to 4 kilonewtons, and then R is equal to 20 meters. And therefore, this gives us as a 4 by 20, which is just 80 kilonewtons meters, and this is clockwise, so it's clockwise like so. Great. So what else? This is about it. So we found the angle. We have found the angle. We have also found the moment, which was quite direct. Right. So this is about it. And I hope the video is helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.